lessons. Oops, go back down for a moment and pull out our lovely printout of the day. It's there. They did not get big, so we can go here. All right. So with this, my friends, we're going to work with standard position angles again. We have this lovely thing called a unit circle that you see being pulled up. This whole thing you'll have completely memorized by the end of next week. And you have a summary of everything that has on the unit circle in a way that puts it all in an organized manner. So we've got to do a couple different things right now. We're going to learn some terminology that you're going to hear me use on a regular basis, okay? First things first, we're going to use what's called reference angles. And what is a reference angle? First of all, you will always see me abbreviated RA because I am too lazy to write the whole darn thing out when I'm drawing it on diagrams. Plus it takes a lot of space. So a reference angle is going to be the following. It is going to be an angle between the terminal side and of an angle. Let's just put this way, of an angle. And this is the key part right here. And the closest, see if I can spell closest right today, x-axis. Okay, write the definition down, and then we're going to do a couple examples of this. Okay? Did everyone get the definition down with me so far? All right, so I want an angle between, okay, the terminal side of an angle and the closest x-axis, because what this does allows us to quickly calculate things without having to use big numbers. Oh, what a concept, right? Let's make it easy on ourselves as possible. All right, so we're going to let an angle right now be represented as 150 degrees. Guys, draw the standard one. Now, I'm going to give you some hints on here. The middle one is at 45 degrees, so it goes right in the middle. And when you're working up here, it goes up 15 degrees, then you're at 30 degrees, 50 degrees, 50, 60. So it goes 30, 45, 60. So it's just always that pattern. So when you're doing 150 degrees, you start with your initial side, and then you will end up going to where it's just 30 degrees above. So here to here is your 150 degree angle. Everyone with me so far? Now, definition of a reference angle. The angle that is between the terminal side and the closest x-axis. Okay, you guys agree with me? This is my terminal side. Is the closest x-axis the positive x-axis? No, it's over here where? The negative x-axis. So what I'm talking about, my reference angle is this angle right here. This is your reference angle. Can anyone tell me the measure of that reference angle? Yeah, because you went from 150 to get to what? 180. So my reference angle, we easily find that just by going 180 minus 150, which gives us what? 30 degrees. So our whole goal is to always, no matter what, get back to that x-axis. And I'm going to tell you right now, we're going to keep it really easy on you. Most of the time, your reference angles are going to be 30, 45, 60, 90, or 0. We try to keep it really easy numbers, but we need to make sure we know how to get there. Now, same rules still happen with radians. It's just I'm using angles right now because it's easier to see quicker. Would you guys agree? I hope you guys are like, yeah, it's just quicker with degrees right now. All right, let me give you another one and see if we can do the reference angle for this one. Okay, so this time, please go ahead and do 240 degrees. All right, so we're going to draw in first. I'm going to use my purple here. Our initial side. Now remember, it's a positive 240. So we start, and guys, do we stop at 180 or do we keep going? This would be 30 more, 15 more, 60 more. This would be your 240 degrees. So that would be my angle. Okay. Which way do I go to get my reference angle? Do I go from that terminal side? Because here's my terminal side, right? Guys, do I go down to the y-axis? No, which way do I have to go? Up. Oh, crap. Okay. Perfect. I go back, and now this is my reference angle. Can anyone tell me what that reference angle measurement is? How did you get that? It goes back to 180, right? It's just 60 further than 180. So my reference angle measurement is just literally going to be 240 minus what? Which is 60 degrees. What do you think about reference angles? I'm going to give you one more, but you don't have to write it down. Are you guys fair with that? Because I want to be able to use these and I can erase mine. You guys can't erase yours. So I'm going to give you one more. Fair? Okay. All right. Please do not write it down because I don't want you to take up these. I want to use these circles for something else. What if I had over here one of them and my angle is 315 degrees. So I go all the way around and this is my actual angle. Where do I put my reference angle? Where do I start? Terminal side? Do I go down or do I go up? You go up until you hit, oops, don't know why that did that, but hey, we'll fix it right here. It goes up, it goes to the closest x-axis. Now, this right here is 315 degrees. What is going to be my reference angle? 175 or 145? Guys, if I'm going all the way around, what do I land at? 360. So to find the reference angle, I just really got to go 360 minus what? 315, and I get what angle measurement? Did you notice strategically the three angles I just had you use as reference angles? 30, 60, and what? Sound familiar? We work with special right triangles that had those angles in it. So yeah, so that's the way you think about it. Now here's the cool part. Someone goes, well, what about over here? Well, those should be easy. That's at 30 degrees. What's my reference angle? First quadrant, always easy, schmeezy. It's the other ones you have to think a little bit more about. Okay, so that is where I wanted you guys to go on reference angles. Beautiful. Okay, coming back here. Now I have a thing called a reference triangle. Oh, wait. Did I say anything about special right triangles being reference triangles earlier this week? Was it end of last week or earlier this week? I can't remember what it was. We said our special right triangles. But what is a reference triangle? It is the following. A right triangle between the terminal side of an angle and is perpendicular to the closest, because that's what makes it the right triangle. Are you guys with me on that? To the closest x-axis. Now someone goes, Gregerson, I am not following you. Write it down and then you're going to catch on to it real easy. Perpendicular means you intersect at what angle measurement? Perpendicular means you intersect at 90. So that's why we're getting a right triangle. Okay? So here's what we're going to do. We're going to build it together. This is why I left it alone for you. Okay? So let's go back. And actually, I'm going to go back to the 315. I should have just left it on there. Guys, let's go ahead and let's graph the angle that's 315 degrees, okay? So when we do that, we start with our initial, right? And then we go all the way around to this spot. Notice, am I going outside of that circle? I could keep extending it. We're going to keep it just so it's on this circle. That circle is a circle that has a radius of 1, but we know that's 350 degrees. Now, here's the cool part. To find a reference triangle, you always go to the terminal side and you pick the point where your terminal side ends on that circle. Then you draw it perpendicular to the x-axis. Automatically, we make what type of triangle? Right triangle. Now, here's where your reference angle comes in. You told me the reference angle right here is how many degrees? There's your reference angle. You told me the reference angle when I showed this to you a moment ago was 45 degrees. Guys, what type of triangle is this triangle right here? Our whole goal is to make reference triangles that are 30, 60, 90, 60, 30, 90, or 45, 45, 90. I know, isn't it scary that past comes together? Oh, I'm sorry about that, guys. Sometimes your past helps you in the future. Okay, now, let's try another one that's kind of fun. Are you guys ready? Okay, so how about we do this? Draw with me a 120-degree angle, okay? So I'm going to do it in purple again because I don't know, I'm just really liking purple. All right, so we have our initial side. 120 degrees is what quadrant? Second. And it lands right here. This is actually 2 scale. So that would be your 120 degrees. Okay, talk to me. Where's my reference angle? Do we go towards the y or down to the x? What's the measure of that? 60, because 180 minus 120 is 60. Oh, now let's draw in the reference triangle. We go to where it hits the unit circle, and then I draw it straight down so it's perpendicular to the x-axis. And then you just close it up and look right here. What did we make? Yeah, we literally made, I'm going to put this back over here, a 30, 60, 90 triangle. Kind of cool, isn't it?
That's pretty sick.
Okay, it is pretty sick because we're going to use it like crazy in a moment. Are you with me so far? All right, here's what you have to do on homework. Find reference angles. What do you think you got for homework tonight? And we can do it. They will change between degrees and radians and basically and coterminal angles. I think you'll survive over on homework for the weekend, but wasn't that an easy place to go? All right, so now I'm going to stretch your mind just a little bit further, okay? Now we're going to make what is called the unit circle, and I'm going to be putting lots of different concepts together today. If we don't finish, the world's not done to come to an end. You've got everything you need for homework at this point. But here's what I need for you to draw right now. We need to draw the 3 special right triangles when they have 1 for our hypotenuse, okay? So, when we do this, so here's the 3 special right reference triangles. Reference triangles. I'm going to see if I can enlarge this so we have them on here. Okay, first one. Did we have a 45, 45, 90 triangle?
Yes.
So when we have an isosceles right triangle, what is always going to be the measure of those angles? 45. AKA, here's my reference angle. Are you guys with me on that? The hypotenuse is going to be 1. If that is the case and you're solving for the missing sides, it ends up being root 2 over 2 and root 2 over 2. This is like at the very end of when we practice special right triangles. This is what we had to find. That was really crazy. So it would be root 2 over 2. Okay, so that's the first reference triangle you need to know. All right, our next reference triangle, I'm going to go blue. We're going to stretch it this way. And I'm going to put the 30-degree angle right here. So that's when my 30-degree angle is my reference angle. My hypotenuse is still 1. This side is going to end up being 1/2, and this side ends up being root 3 over 2. And that makes sense just because 60 is bigger than 30, so its side that's opposite it is bigger. So that is, this time I call it the 30, 60, 90 triangle because the 30 is what we're using as our reference angle. Okay, what's the only reference angle we haven't talked about yet? 60. So we just then flip it on its side. My reference angle is now 60. This is still 1. Well, what's the long side here going to be? Root 3 over 2, and this is going to end up being 1/2. Those are the 3 special right triangles that we're going to use as reference triangles to create a unit circle. Okay, here is the formal definition of a unit circle. A unit circle is a circle drawn on a coordinate plane whose center is on the origin and whose radius, are you ready for this, is 1. 1 unit. Now, if you look at this, I'm going to shrink this down. Do those lines look a little familiar? Okay. Those lines represent increments of either 30, 45, or 60-degree angles. Obviously, 90-degree increments are your axes. So we need to be able to put on these all those values. So we're going to fill in lots of stuff, and eventually you're going to get really good at this. So first thing we're going to do is going to go with what you know. Do you guys agree with me? You think you probably could figure out degrees. So let's do the degrees going around the circle. So I'm going to do this in black. You could do this in like in pencil, whatever. Okay, starting here, if I start on the positive x-axis, how many degrees am I at? 0. The next increment is at 30 degrees. The next one after that is just 15 degrees further. It's 45. And then the next one is 60. Guys, when I hit the y-axis, how many degrees am I at? 90. Okay? Your next one, my friends, is going to end up being 120 degrees. Then you get to 135 degrees, and then this one should sound really familiar. 150. And then when we finally land on the negative x-axis, what do we got for degrees? All right, can anyone probably tell me where the next one's going to be? This is the 210, right? We're going 30 degrees. We're at your 210. Then we're at the 45-degree one. So we go 15 degrees more. That's 225. Then we hit at 240. We're then at 270. Because that's 90 more than 180, right? And then this is where you have to kind of get used to these and you get good. This is 300. Are these all sounding familiar from the last couple of days? Yeah. So 315. Then you're at 330. Oh, where would I end at? 360. All right. Now, to save time, just know I'm really great at converting radians to degrees. No, I'm not. I just have them memorized, and I've memorized patterns. I'm going to help you put them around, and you're going to catch on to it really quickly. Because you guys, I'm going to give you the smart compliment, but you're pretty darn smart, so I think you can do this. Are you guys ready? Okay. How many radians are you going to have if you start at 0 degrees? You're at 0 radians. Now, when you do this, 30 degrees, and if we did converted that to radians, ends up being pi over 6. So this is pi over 6. Can anyone probably guess what, I'm just saying if you can guess, what 45 degrees would be in radians? It's going to be pi over 4. Right on. And guess what 60 is going to be? Pi over 3. And then 90, we were doing this a lot the other day, and we got what? Pi over 2. Now, I want you to think about this. I went 30 more. Now, this is how easy it is. Guys, if I was to draw in a reference triangle right here, oops, I wanted to change color. Excuse me for that. If I drew in this reference triangle, what's my reference angle there? It's 60. Okay? That means that my radians are going to be So when I'm over here, this is going to be over 3. What quadrant is that in? So it's just under what number? 2 pi over 3. Now do you see why I was forcing you guys to tell me what quadrants these look like? Because it helps me figure out my radians faster without having to think quite so hard. Okay, 135. Can anyone please tell me what is going to be my reference triangle and angle for this one? From here to there. Oh, 45. So guess what my radians are going to be over? 4, right? Because what's my radians over here with 45? 4. Okay, I'm in the second quadrant. I'm just under what lovely number? So what's just under 4 over 4? 3 pi over 4. Okay, are you guys starting to see slight patterns with that a little bit, I hope. All right, let's do this next one. Friends, can anyone guess what probably would go over here? It's going to be something with 6, right? And we're going to always have pi because it's radians. Okay, but that's in the second quadrant. It's just under. Oh, wait, what would be my reference angle for that one? No way. Are you guys following with me where this is going? Yeah. So then what is going to be our value over here? Our value for this is just going to end up being pi. All right. I think I've kind of like messed up my color schemes I was planning to do, but we'll go back to it a little bit. All right. I'm going to delete this just for a moment. We'll come back to it in a moment. Okay. Friends, you should be able to help me knowing reference angles, what goes in for the radians. To get to 210, how many degrees did I have to go from 180? 30. So my reference angle is 30. 30 degrees is over what values? I know I'm going to have a pi there. Okay. Over 1 or under 1? So what's just bigger than 6? 7. There you go. 225. What's going to be my reference angle? 45. So I know my radians is going to be over 4. So then this is going to end up being what value? Do you see now why I was making you learn over and unders yesterday? Is it making any sense so far where all these patterns are coming from? It's scary what it does. I'm just telling you. It's like, darn it, it's making sense in this crazy mind of mine. Okay, guys, 240. What's your reference angle? 60, right? Oh, 60 is pi over 3. So I have to do what? Over 3. Anna, I think you're seeing some patterns today that I absolutely love. Okay, now everyone should just know what 270 is because we kept using it all the time yesterday. 3 pi over 2, right? Yeah, 3 pi over 2. You should know that one from it. And what's its reference angle? Technically 90. All right, keep going with me, guys. 300. To get to 360, this would be the direction of my reference angle, right? How many degrees is that? 60. So what's going to be the bottom of my radians? 3. But it's just under what number? 2. So 3 times 2 is 6. What's just under that? 5. So we go 5 pi over 3. Okay. Reference angle for 315. 45. So it's going to be over what value? We know there's going to be a pi there. Oh, we're in the fourth quadrant, just under the number 2. So 4 times 2 is 8. If we're thinking fractionally, 8 over 4 would be 2, right? What's just under that? All right, last one. Well, actually, there's 2, but last one we have to think hard about. 330. What's your reference angle? 30. And so we get what? 6. Well, what's 2 times 6? So just under 2, be just under 12 is going to be what? And can anyone tell me what 360 is going to be? Not as mind-blowing as it could be, right? Now, we need to fill out the next part, okay? Now we need to fill out, and this is where I messed up with using my colors earlier because I wanted to do the reference triangles. We need to use our reference triangles to find our trig. values. Okay? Now, this is where people can get mad at me. Didn't we just solve special right triangles using sine, cosine, and tangent? Okay, at the base of this, here's what I need for you guys to write down. Are you guys ready? Cosine theta. So the cosine of an angle equals the x coordinate. Just write it down right now. So this is always going to be our x value. Our sine theta is always going to be the value of the y coordinate. And tangent theta is found by going y over x, or aka sine theta over cosine theta. Guys, what we're trying to do is not to use our calculator to solve for sine, cosine, and tangent. We're going to be able to come up with exact values based off of what we have. Now, when we do this, and we talk about the unit circle, oh, did everyone get that written down? I just totally moved it on you without even asking, and I'm so sorry. Are we good with this? All right, now I'm going to help you figure this out. I want you to look, what color did I do my 45? Okay, I did it in green. And I think there's blue. Okay, so when I get here to this value, am I on a coordinate plane, so do I get an x and y coordinate, right? So, using this, I need to figure out a triangle. Now, again, if you don't want to draw this because it's going to get really messy, you don't have to. But I'm going to draw in and make what type of triangle here? Am I making a right triangle? And AKA, can anyone tell me which one of my reference triangles I'm using? I'm using a 30, 60, 90. So you agree with me, this was 30. What was this again? 1. What's my vertical height right here? What was my horizontal distance? Root 3 over 2. That was from my reference triangle up here. People, the cosine of 30 degrees is the x. Well, let me go back here for a moment. So sorry. Where did it go back? Hello, please go back. Okay. The x coordinate, the ordered pair that goes right here, is my horizontal value on my special right reference triangle. It's root 3 over 2. That y value is 1/2. Based off of where my x is always the horizontal side of my reference triangle and the y is always my vertical side. Now, guys, here's where we're going to just back up for a moment. What happens if my point's at 0? Well, this is when you should just know how far over. How far over am I if the radius is always at 1? 1, 0. Okay. See why we could not probably have a real brand new big homework today.
Audrey Hamill.
All right. So, what's homework?
Audrey Hamill.
Worksheet.
Thank you.
And then that's due at 8 a.m. And then just do a Kahoot, play solo. Are you guys with me on that? I think I said solo play, but if not, just play solo so I can register you all. Are you guys good with that?
For the homework, is it based on completion or?
For the Kahoot? Or the Kahoot? Yeah, but just you can play it. So I guess you play it. How much fun you want, but just go through it. You're gonna see it pretty easy again. But what I just care about is more work. It's just a practice. Kahoot is gonna make you practice what we've been doing. It's just practice. It's just to try to reinforce what we've done the last 2 days.
Oh,
Thank you. All right, you're welcome.